Hello, young neighbors. Welcome to Junior Science. Today we're going to do some very exciting experiments and find out something about electricity.
Now, we've all seen the things that it does. It gives us heat and runs clocks and turns motors and makes trains go. It even provides the power to run our television sets. But what is electricity?
Well, today we're going to find out.
I'm sure you all know that everything in the world is made up of tiny particles called atoms.
Well, all atoms contain electricity. And so actually everything in the world, including our own bodies, contains tiny particles of electricity.
Now, every atom has two parts. A heavy part in the center called the nucleus, and some tiny particles of electricity that whirl around it. These particles are called electrons.
When a current of electricity flows in a wire, what actually happens is that electrons jump from one atom of the wire to the next atom very, very quickly.
Now, if there are a lot of electrons in one place and very few in another, and the two places are connected by a wire, the electrons here have enough pressure to push themselves through the wire until there is the same number of electrons here and here. And this flow of electrons is called an electric current.
Now, we can't actually see an electric current flowing, but we can see how this works by using water as an illustration.
If we have a little colored water in one funnel and a lot of water in another, this water has more pressure. And when we connect the funnels, the water will flow through the tube until both funnels have the same amount of water in them. Now, the funnel with a lot of water is very much like a dry cell, because in a dry cell there are a lot of electrons waiting to go to work and push themselves through a wire. Nowadays, we use dry cells in flashlights and portable radios and lots of other things without giving them a thought. But have you ever stopped to wonder how a little thing like this can carry enough electricity in it to light a bulb or run a radio? Well, to understand why, we have to go back more than 150 years. Somewhere around 1780, an Italian scientist named Galvani was dissecting a frog on a metal table. By chance, his metal knife touched both the table and the frog's legs at the same time. Galvani was surprised to see the dead frog's legs twitch when touched by the two metals. The reason this happened was explained by another Italian scientist, Alessandro Volta. Volta said that when the two metals were connected by the fluid in the frog's legs, there was a chemical action between the fluid and the metals, which produced an electric current and made the frog muscle twitch. Thus, produce electricity when touched by two different metals is called an electrolyte.
And we have such fluids right in our own bodies. One of them is the saliva in our mouths. It is an electrolyte. And since you know that a current of electricity is produced when two different metals are connected by an electrolyte, you can make a very tiny current flow right through your own tongue and actually taste the electricity. Just take two different metals. A clean penny and a clean dime will do fine. Touch them together at one end and put your tongue between them. The bitter, sour sensation that you feel is the taste of electricity, which is passing through your tongue. And that electricity is created by the chemical action of the two metals and your saliva, which acts as an electrolyte. Now, electricity can be made with any two metals and any electrolyte. Volta, the scientist we just mentioned, used zinc and copper as the two metals, and a strong solution of salt as the electrolyte.
In an electric cell, there are more electrons on one metal than on the other. And just as the water flowed from the funnel that was full to the funnel that was less full, when the funnels were connected, so electrons flow from the metal that has a lot of electrons to the one that doesn't have as many when the metals are connected.
The reason this happens is that the electrolyte in the cell acts more on one metal than it does on the other.
In Volta's cell, which we call the voltaic cell, the electrolyte starts dissolving the zinc, and each atom of zinc, when it dissolves, leaves behind it 2 electrons. Pretty soon, the zinc has a lot of extra electrons piled up on it, just waiting for a chance to be connected to the copper and make an electric circuit.
Now you can make a little voltaic cell in your own home, one that actually works. All that you need is a penny, a galvanized iron washer, and a small piece of blotting paper.
Soak the blotting paper in salt water or vinegar. That will be your electrolyte. Then squeeze the blotting paper between the penny and the washer. And there's your voltaic cell. 2 different metals and an electrolyte.
Now, this cell won't give you enough electricity to run a washing machine or even to light a small bulb, but it will give you electricity, and you can detect the electricity with a meter. Where do you get a meter? Why, make one, of course. And here's how you do it.
Take a pocket compass and wind about 50 turns of fine insulated wire around it. When you've finished, turn the compass so the needle is under the wire. Now, when an electric current passes through a wire, that wire becomes a magnet and can attract iron filings or turn a compass needle. And if the wire is wound into a coil and an electric current is passed through it, the magnetic field around the wire is stronger, and the needle is turned even more. So we can use the compass as a homemade meter to detect an electric current. Now, if our little homemade voltaic cell can really produce a current, the current will pass through the coil and create a magnetic field which will make the compass needle move. So, you see, our homemade voltaic cell really produces electricity.
Now, the most common form in which we see the voltaic cell today is as a dry cell.
And here's something I'll bet you didn't know. A dry cell really isn't dry at all. If you cut one open, you'll see that it isn't. In a dry cell, the metal that has all the extra electrons on it is the same as the metal in Volta's cell, zinc. But instead of being put inside the container, as in the voltaic cell, the zinc is shaped so that it itself is the container, like this. Then, instead of copper, as in the wet cell, the dry cell uses a carbon rod, which is put right smack in the center of the cell. And as the electrolyte, the dry cell uses a paste of ammonium chloride and manganese dioxide. So you see, the dry cell isn't really dry. It has a wet paste in it. Now, when we connect the zinc part of the dry cell with the carbon, electrons flow from the zinc to the carbon. And these electrons can be made to do work, like lighting a bulb.
Now you know what an electric current is and how it is produced by a dry cell.